Hello everyone, welcome. In this video, we will explore a key concept in data science exploiting data analysis or EDA. EDA is a way to understand your data by visualizing it. Using Python's powerful tools, we can create visualizations that can help us find patterns, identify problems, and make information decisions. Let's dive in. Exploratory data analysis is the first step in any data science project. It helps you to see your data from different angles, discover trends, and detect any issues early on. In this video, we will talk through a few visualization techniques in Python that can help you in your EDA journey. We will be starting with the construction bar graphs with overlays. Let's start with bar graphs. Bar graphs are great for comparing categories. In Python, we use libraries like matplotlib or Seanborn to create these graphs. Sometimes we need to add extra slides to our bar graph. This is where overlays come in. You can add a trend line or even another bar graph on top to show a relationship or pattern. For example, you might add a line to show how sales are increasing over time. Python offers many tools for visualization. Matplot and Seaborn are the most popular ones. They let you customize everything from color to labels, titles, and even notations, making your charts more informative. Constructing contingency tables. Now let us talk about the contingency tables. These tables show how two or more categories relate to each other. For example, you might want to see how gender affects whether someone likes or dislikes coffee. In Python, we use the Panda library to easily create these tables. They help us to see how different categories are distributed and can reveal important insight about relationship in data. Our next subtopic is constructing histograms with overlays. Next up are histograms. Histogram shows the distribution of continuous data, like how people ages are spread over different age groups. You can also overlay a normal distribution curve to check if your data follows a common pattern. Our next subtopic is binning based on predictive value. Binning is another important technique. This means grouping data into intervals or bins. For example, you might group ages into ranks like 0 to 10, 11 to 20, and so on. In EDA, we often bin data based on its ability to predict a target variable. First, identify the target variable and the one you want to predict. Then, look at how other variables relate to it. Finally, group the data into bins based on the relationship. Our next subtopic is enhancing visualizations and notations. Visualizations are more powerful than you add notation. Notations let you highlight specific points, trends, or outliers. You can use arrow, labels, or text boxes to explain what's happening in your chart. An arrow can point out a peak in trend, while a text box can provide a deeper explanation of a specific data point. This makes your visualization easy to understand. Next, we will be talking about the interpreting visualization in slides. Once you have created your visualization, the next step is interpreting the insights. It's not just about making pretty charts, it's all about understanding the pattern in your data. Ask yourself, what are the key takeaways? Do any trends surprise me? How can the insights help with decision making? followed by applying EDA to world data scenarios. EDA is used in many real world scenarios, whether you are analyzing sales, trends, studying customer behavior, or looking for pattern in medical data. EDA help you make sense of complex data and drive discussions. That's a quick overview of exploiting data analysis with Python. We have covered bar graphs, continuous tables, histograms, and more. Remember, EDA is all about exploring your data and uncovering insights that can guide your analysis. Thank you for watching and be sure to check out more Python tutorials to level up your data skills. Happy coding!